Airbyte team, we're super excited you were able to join us today. Hope you're going to be excited for some great talks, and you hope that you're able to enjoy the food, drinks, and everything. DataBytes is a big effort on our end to create the go-to community for in-person events among data engineers and machine learning engineers and enthusiasts from all areas of the city and of the Bay. So today we're super excited for the talks we have for you. You're going to be hearing from our very own AJ. He'll be talking to you more about what we're working on over at Airbyte. And then you'll be able to hear more from our friends over at Qdrant and AgentCloud. Each talk is probably going to be somewhere between 10 and 15 minutes. We will have some time for you to ask some questions after each one. And we've designed tonight so that you'll be able to see a common thread among each. So if you have questions on how all these pieces fit together, you'll also have an opportunity to do so at the end. You will also see QR codes everywhere at some point throughout the day. Feel free to scan them. Usually it's us asking for feedback on everything ranging from food all the way to Teo talking too much. You can give comments on all of the above. That being said, I am not the focus for today. It is the gentleman over here on my right. So I'm going to pass it over to AJ. Amazing. He's got a mic and everything.
Hello.
Bye, everybody.
Everybody hear me? All right, I'll try to use this and I'll try to speak into it because we have some people way in the back. I see you. So welcome and thanks, Teo, for the intro. I'm really excited to be presenting today with some awesome technology partners today. So I'm going to start with, from the Airbyte side, how to fuel AI with great data. We're going to talk about later on, these folks are going to talk about all the cool things they can do in RAG use cases. And all of that starts with the data you need getting into the pipeline that's going to provide it into the AI application. So we'll cover some things about unstructured data, some trends, how you can get access to unstructured data. We'll talk about our new offering, Airbyte, what it is and why. I'm actually not going to, actually I might have a demo. I didn't know we were going to have a podium, so I scratched the demo and maybe we'll bring it back. And then we'll talk about local versus cloud execution and some new features. So if you're familiar with Airbyte or if you're not, we are a data movement platform. We have over, 350, depending on how you count, some very, very large number of hundreds of connectors that you can load data to and from. And all of them pair with each other. We've been focusing on peace of mind, flexibility of deployment, and a robust connector library. And we have these main offerings. Cloud, if you just don't want to think about anything, deploy it to our cloud. OSS, if you want to own the infrastructure yourself and run it open source. And then enterprise, if you want to balance the peace of mind with also having control over how it's deployed. So we realized early last year that there was a gap in what our Airbyte users had access to, and it's becoming more apparent. We had great tabular data sources and we had great sources, interfaces for APIs, but we didn't have great data for unstructured. So we invested a lot this past year in unstructured data sources, websites, PDFs, books, Google Docs. Nobody has yet built a YouTube transcription scraper, but I'm waiting for that one to come around. But yeah, we have news articles, lots of ways you can get data now. GitHub is not always considered a unstructured data source, but it's one of my favorite unstructured sources because there's very rich data in there. And yeah, you can imagine all the places you can store data, all the places you might want to land it. And the second gap we uncovered was that these new things arriving on the scene, vector stored databases, we didn't have any support for them, we didn't know how to deal with them, and our users weren't sure how to deal with them either. So not only did we build the vector store destinations, we also thought about the paradigms. We talked to users on the AI side. What do you want and what do you expect when you're loading into vector store databases? And people generally want to be able to do embeddings and chunking without code. So we invested a lot in that, and now you can do basically data from anywhere into any, not just these four, but other vector databases as well. And you can build it all in Airbyte with a friendly UI. So what we then learned is that, okay, for AI use cases, it's great to have the unstructured sources, it's great to have vector store destinations, but do you want to spin up a Kubernetes cluster? Do you have permissions from your admin to get the credit card to go sign up for a service while you're on your POC or whatnot? And are you going to reach for a service or are you going to reach for a library? And what we found is that most AI developers are going to reach for a library. And Airbyte wasn't fitting that gap yet. So what we did is we built Airbyte. So Airbyte brings the power of Airbyte to every Python developer. So every connector, and there are over 250 of our total connectors that are written in Python, you can run those directly now in Python locally. That's a really great unblocker for ML teams who are working in Jupyter notebooks. The demo, if I do get through it today, is in a Google Colab notebook, and you can open it up yourself. And we're really trying to bring that library of connectors to you wherever you're doing AI. So you can run anywhere, reduce time to value, just build and iterate locally, fast prototyping. In a lot of cases, you don't want a UI. In other cases, you do want a UI, but sometimes you don't. And so you don't have to go through that if that's not what you're looking for, and it's flexible. So I know you might not be able to see the screenshot here, but it's only 3 lines of code with 2 comments and 2 more blank lines of code. But basically, I'm going to walk you through the steps of using Airbyte. And the very first step is you create a source. You just call get source, and you pass the name of the source, source-github. Then you set whatever configurations needed for that source. So it might be the list of repositories, your personal access token, things like that. And then finally, you read from it. You just call read. So in less than 10 lines of code, you can get data from all of those 250 sources into wherever you need it next. And later, if you want to deploy it to production, we'll be here with cloud and whatnot. I'll talk about that in a second. So for those of you where 3 steps is too many steps, here's the 1-step version. The speed run data engineering. So in these 12 lines of code, it's actually just 1 statement wrapped with a line limit of something like 40, 50 characters. You get the source. What's the name? Source GitHub. Pass the configuration. What streams you want. Issues, pull requests, and stargazers, and read. That's all you have to do. Designed to be as simple as possible. We iterated on this quite a lot to get it just down to the nuggets of what was necessary. You can optionally provide a pip URL to that, or use your local connector you've been building with the Airbyte connector builders. You can pin that version, so this will be stable forever. Yeah, so you can do all the things you'd expect in a Python library. And so this fits into the Airbyte Cloud and OSS and Enterprise family as a complement. We're not trying to make you choose one. We're trying to make sure that whatever you need to deploy, whatever you need to run, it's there. This is just 6 weeks ago that we launched, and we've been fastly iterating since then. So what we want to do is make sure that whether you're doing Gen AI, machine learning, data warehousing analytics, and data engineering, you just know how to get data from wherever you want to get it and land it where you need it, when you need it, in a way that scales, and that Airbyte or Airbyte just becomes synonymous with getting my source data. Let's talk about the choice of why you'd want one or the other. So if you want peace of mind and you just want to point and click and not worry about where it's running, how it's running, what happens if a server goes down, use cloud, because that will give you redundancy of the cloud, ease of use. It's just on our service. You don't have to worry about security. We're taking care of that. If you want full control, go with Airbyte, and it's exactly the code to run it locally or whatever you need. Now, just this week, we are announcing Airbyte and Airbyte together. So if you want the combination of running in the cloud, but controlling locally and executing with code, you can do that too. So again, code you might not be able to see from where you're sitting, but now Airbyte Cloud users can run jobs from Python. So if you're an existing Airbyte user, you can just today pass in your connection ID and run it locally, check on it, rerun it if it fails, those kinds of things. And we're really excited about this. We can actually read data from a cloud sync. We're supporting right now BigQuery and Snowflake. So if you ran a sync in cloud, you can actually read that data directly into Python for the downstream transformations you want to do, pandas, LLMs, etc. Okay, so we're not done. Like I said, we just launched 6 weeks ago, and there's a lot more to do. We have a fantastic community. Several people are opening issues and pull requests, and we hope that you'll join the community and contribute as well. It helps everybody when you do. We will We're also building the ability to deploy Airbyte Cloud using Airbyte. So if you want to automate creation of cloud jobs or configuration, you'll be able to do that shortly. More cloud destinations. Currently we have, if you want to create a pipeline in Airbyte just locally, you can load to Snowflake, BigQuery, Postgres, DuckDB, MotherDuck, and I think that's it, maybe one more. And if you don't specify, you automatically get a free DuckDB database. Thank you. You're welcome. Everything is behind the scenes, has a SQL backend, even if you don't request it. DuckDB is really powerful and fast, and so we just give it to you for free. And yeah, we are working also on the ability to run low-code sources from YAML. So if you're an Airbyte user and you've used our no-code builder, where you just go in and click until you have a connector, you copy-paste from the endpoints, configure it with a visual interface, that outputs a YAML file, and soon you'll be able to provide that YAML file directly to Airbyte. All right, so there's some resources here to get started. You can report bugs with our GitHub issues, etc. I'm going to pause for questions while I see if we can load up a quick demo. Questions? Yeah?
Any plans for like other languages other than Python?
It's a good question, and we do get that question often. Python is right now kind of the leader in the AI space, and it is kind of the lingua franca that most libraries require or expect. So not right now. The other benefit of running in Python currently is that we just natively can install Python-based connectors in a Python virtual environment. So if there's one common denominator right now, it is that Python can run Python. We have thought about and may in the future have Docker-based executions, and that really opens up any language possible. We did not want to make Docker a requirement for Airbyte because there are Docker and Docker situations just get messy, and it just doesn't work in some scenarios. So we did not do that yet, but in the future that absolutely could open up. Yeah. All right. Actually, I think I'm close on time, so I think I'm going to go ahead and hand it off, and the next can come up. I think it's there. Thanks, everybody. There you go. And you can use this if you like.
Thank you. I'm absolutely pumped for Airbyte. Can't wait to see what happens. Just give me a sec. Plug this one in. Oh, this is visible. Can we make it not visible? You know how to do that? The presenter view?
Just close it.
What's that?
Just try to close it. Sorry.
No, what if I want to have the notes? Anyways.
Oh.
Alright, let's wing it. Screw it. Oops. Alright. Hi guys, my name is David Muriel. I'm here from Qdrant. We're a vector database company, and today we're going to talk about how Qdrant adapts to all the things that Airbyte's doing and how it fits the entire context of AgentCloud as well. So let's start with a basic example just to kickstart everybody's experiences with ChatGPT. My colleague Kasper asked GPT the other day, what was the capital city of Germany before Berlin? Now, you guys can't see what's on the screen, so let me give you the output. The capital city of Germany before Berlin was Frankfurt am Main, from 1815 to 1866. So now it gave us an answer based on the context that it was able to work with. However, is this really true? Was it really Frankfurt before Berlin? if you do a basic Google search, you'll find that it was Bonn. Between 1949 and 1990, Bonn was the capital of West Germany, and Germany's present constitution, the basic law, was declared in the city in 1949. Only after the unification became Berlin. So what's the problem here? Why was GPT not able to give us an answer, even though on something as basic as this? It was probably trained on this Wikipedia information. So why was it giving us a wrong answer? The issue here is that large language models work with a limited context. They're essentially working with information that is frozen in time. And sometimes they hallucinate. Sometimes it's not dependent on what they know, but what they can access at a certain point in time. So what we need to do is give a naked LLM some context to work with. So when we ask it a question, we say, use the following information to answer the question. Then we give additional information on Berlin, and then once we provide additional context, it gives us the correct answer. So this leads us to the elephant in the room, the concept that we've all been hearing about over the last year or so, retrieval augmented generation, or RAG. Raise your hands if you've heard of RAG. Okay. So we're going to skip some initial concepts here. RAG is dependent on semantic search, and this is what we're all about here at Qdrant. We're supporting almost 90% of our business is RAG, and customers and companies that use and produce RAG-based products. So in this presentation, we're initially going to focus on some theoretical considerations about semantic search, and then we'll talk about our company, Qdrant, and how it provides semantic search on a larger scale. So there are two components of providing semantic search. There is the indexing portion, and then there's the search portion of semantic search. So semantic search depends on vector embeddings. And these vector embeddings are created by a neural encoder or a specific large language model that transforms document chunks into vector embeddings and stores them in a vector database. These are high-dimensional vectors that are basically stored in Qdrant as a knowledge base and then are accessible for search. In the second portion of semantic search, what we're doing is we're querying a vector database. We're querying it through a neural encoder, which creates a query embedding that queries against the vector database, and a calculation is made using cosine, similarity, or dot product to retrieve semantically relevant information. This is essentially, these two parts is essentially how vector databases work. Now, how does semantic search do all of these calculations? It uses an algorithm called approximate nearest neighbors. So initially, companies were using k-nearest neighbors algorithms, but those were not able to scale. The approximate nearest neighbors is easier to scale, but it doesn't have as high of an accuracy as k-nearest neighbors, which would get complete 100% results over all of the documents queried. The most popular approximate nearest neighbors algorithm is HNSW, and it is thought to be a state-of-the-art algorithm in this area. It's a graph-based data structure with edges created between points which are close to each other. So let's roll back to retrieval augmented generation, and now see how semantic search fits the whole picture. So without RAG, a user just communicates with a naked LLM, gives it a prompt, and receives the answer back from the LLM. Now, as we said in the Berlin example, this can be any type of an answer depending on the context window of the LLM, sometimes right, sometimes wrong, depends on the situation and the tokens. With RAG, we're introducing the embedding model and the knowledge base as part of the entire structure. So when we send in the question, we're running it against the embedding model to create a query vector, which queries against the knowledge base that has all the vectors stored in it. This knowledge base is Qdrant, and it comes back to the large language model with that additional context. So this is, going back to the Berlin example, when we give a whole story of Berlin coming after Bonn and all of that. So this information is served back to the LLM, which now is able to come back to the user with enriched answers. So, talking about our product, what is Qdrant? Qdrant is a vector database built in Rust. It is, our main principle is the Unix principle. We try to keep our product minimal, focused on a specific thing, offering modularity where need be, but we have a clear picture and a clear vision of the features that we want to provide to our users. We're very focused on open source, and we're going to talk about some of the features that we offer that complement our open source community and their intentions. So, but going back to what Qdrant does on a basic level, Qdrant's main unit of storage is a collection. So a collection has points in it, and points can be string IDs that connect one vector or multiple vectors, depending on the modularity of the data. We have an optional JSON payload which helps with the search. So payload can contain some description of what it is, like a color or a URL, to tie everything together when a search is being conducted. So we can search based on the vector and then additionally based on the payload to get that accuracy. So how do we excel in production? The great separator between what we have and some of the other vector databases. Qdrant, as I said, is written in Rust, and we have a great community of Rust people backing us up. But we also have a lot to offer in Python SDKs. We have JavaScript, TypeScript, Rust, and Go SDKs as well. We incorporate on both single and multiple node setups, and we support and have mature integrations with the majority of LLM frameworks, such as Haystack, Llama Index, DSPy, and LangChain. However, this is just because we're open source doesn't mean we lose sight of the business side of things and what our customers are doing with vector search. So one of our key principles is to make vector search affordable and make it run on even the most budget-friendly machines. So this leads me to the thing that I'm most proud of is the optimizations. Because there's a lot of vector databases out there, but our optimizations really make us stand out. So I just want to mention that vector search is very memory intensive. So if you use LangChain, for example, I think it's almost around 6 kilobytes per vector to process it, and that can add up very quickly. So what we're looking to do is empower people to reduce their memory requirements while still running search quickly and getting the highest possible quality results. So we have two features here, and the first feature is scalar quantization, which I believe it reduces memory requirements by 4 times. And the way it does so, it changes the structure of the vector from a float 32 to an integer of 8. And this makes the search much quicker, much more lightweight, while still yielding the same high quality results. In terms of binary quantization, which is an even more extreme version of this, we're receiving around 32% memory requirement drop, and 40 times the speed up, reducing everything to zeros and ones. So the vectors, if they're 0, they're 0. If they're larger than 0, they become a 1. And something I want to mention is this doesn't affect the information that the vector data that you put in the database. So binary quantization and scalar quantization only operate on the search level. So all of your vectors are kept inside of the knowledge base, but only during the search portion do they access the quantization feature. So the second set of features I want to discuss real quick are what we're also very proud of for scaling, efficiency, and security. and our enterprise customers make great use of them. So the first one is multi-tenancy, and we have a lot of inquiries. Actually, last year we had a lot of inquiries from people when they were still prototyping on whether they should be creating multiple collections for each user. That's something we don't support. We don't think that it's optimal. And we think that the best way to work with Qdrant is to have one collection for multiple tenants at the same time. So from this basic diagram, you can see there's two different users sharing the same collection, and they're divvied up by the payload. So the payload, the user can belong to a group for a tenant ID or something like that, and that's how the vectors are separated and the points are separated in that direction. So what's happening here is you can have vast numbers of users. You can have millions of users sharing the exact same vector database. This is a very serious consideration for efficiency, for cost, and performance. You're updating your collection, you're updating your Qdrant cluster. You don't have to update multiple collections, you just update the one. So custom sharding is the second feature we want to highlight. And this is very important for companies operating internationally, operating in different regions where you want to keep shards belonging to the same collection in different locations. Call it, I don't know, let's say GDPR in Europe. You don't want to share, a healthcare company, for example, doesn't want to share information for European customers with its US branches, and you would go ahead and use the same database, chop it up into shards, host it on different nodes globally, and receive your scalability in this way. So this adds a completely new, these features combined together add a completely new dimension of security and reliability to what Qdrant does. So once combining both features, you can see how you have a double layer of isolation of data. And this is really something that we consider to be the highlight of what Qdrant does in terms of enterprise performance. Because ultimately what companies are going to do, they've been prototyping last year, now they're making serious progress, they want to scale out and try their new products, new applications on a global level. So what can we do to get started with Qdrant? Qdrant's easy to access. Go to our site. We've got a good documentation site with tutorials, examples, spec, different explanations of the concepts. One of the problems with initial stages of working in a vector database company is people don't understand what a vector database is and how semantic search works. So we have a really good concept section that explains everything in great detail. And we have a lot of tutorials that cover some basic scenarios from chatbots to recommendation engines to semantic search for beginners. Pretty much anything that you can think of, we've got most flavors of vector search. You can go to our examples repository in our org. We also have some good recipes you can plug right in, and we try to maintain them daily, weekly, so that nothing breaks. But forgive us if something breaks every now and then. A YouTube channel with my colleague Daniel and I. We have some introductory videos to get people hooked, but then we do some additional advanced stuff for edge cases that might get some additional attention. However, oops, what is this? Didn't know it was going to start playing. Why is it playing? Okay, so Qdrant is available in several ways. So as AJ said, there is a great compatibility between our local access mode in the Python SDK and also the Docker modes that we offer. However, we do offer a SaaS solution as well called Hybrid Cloud or Qdrant Cloud. And as of today, this morning, we're also starting to offer Hybrid Cloud. So what's the difference between Qdrant Cloud and Hybrid Cloud? Qdrant Cloud is a straight up SaaS, so our core open source product on AWS, GCP, and Azure. But as of this morning, you can bring your own cloud host and host it on your own infrastructure. Everything's kept sovereign, all your data the way you want to have it exactly. However, you still use our UI to manage Qdrant's clusters from the interface. So this is a great advancement in Qdrant's vector database offering because it just introduces a whole another level of privacy, sovereignty, and flexibility for deployments. I think that's probably time. You good? Yeah, I think I overshot it. Thank you.
Hey everyone, my name's Andrew. It's great to see you all. So, yeah, my name's Andrew, I'm on the left here. My co-founder is also in the crowd, his name's Ragi. Actually, I think the best thing about LLMs these days is that we can finally show you as Australians how we get around. So, this is a photo of my friend Ragi getting around in Australia. I think this is very cliche, but yeah, pretty much everyone thinks we go around in kangaroos. Look, today we had some pretty good talk. Oh, by the way, I only did that because I've been watching Seinfeld recently, and I just felt the need to do a bit of stand-up. Anyway, yeah, so we heard some great stuff from Airbyte, and I think Airbyte's great because you can connect to hundreds of data sources very quickly. And we also heard from Dave about Qdrant. Now the challenge for us was like, as a SaaS company, we always try and automate things. We always try and put things together. And what we wanted to do was trying to make a solution that everyone can deploy to get their own AI chat apps. Their own AI chat apps deployed in their own cloud, combining these two solutions together, making you build private RAG chat apps. You all know about GPTs. GPTs are great. You can build, if you've got capability to write actions, if you've got great data, you can build brilliant GPTs. But they fall short in a couple of areas. Number one, it's not open source, right? Elon Musk has been recently having some great activity around this area, but it's not open source, it's proprietary. The second thing is that you can only use the models they provide, right? So you can't use like Mistral or any of these other companies. The third thing is you can only upload files. And I think that's a pretty major limitation, right? Everyone's trying to connect a lot more data sources, and files just don't cut it. Next thing is visibility. I spoke to a developer, and he said when he was using the GPTs, one of the things he got really annoyed about was he just didn't know what the vector space looked like. He had no idea he couldn't debug the vector space to make sure he improved his chat app. The next thing, privacy. It's a very serious thing now. We've got CCPA, GDPR, privacy laws are only getting bigger. And sensitive companies don't just want to throw around their data to any vendor. I mean, Microsoft and OpenAI is an important vendor, but sometimes that's not good enough. Sometimes I just need to have it in my own cloud. And last of all, innovation. I think GPTs have been great in terms of, OpenAI in general has been great in innovating in LLMs, but people want more, and people are talking about multi-agents and a bit more capability. So we're here to show you a platform that hopefully delivers on all of these things. We're just growing, we're just new, but we really want to build up support in this area. So I'm going to start with a demo because I think, instead of going theoretical, I'll start very practical. I'll show you the platform, and then I'll walk you through some of the architecture decisions and why we made these decisions. So let me get out of this and pray to the demo gods. All right, so first of all, we'll come over to the platform. So in this demo, what I'm going to show you is how to build a private RAG chat app. Now, in terms of our architecture, just at a very high level, we've built a web application, but we're built on the shoulders of giants. So like I said earlier, we have Airbyte and we have Qdrant, right? These are the two big pieces of infrastructure that we're built on top of. And we're running these under the hood. And if you run this locally, so you can install our application just by going over to our docs. We've got a full guide on how to install it on your machine. But essentially, we'll instantiate under the hood Airbyte and Qdrant already. And this is the app, right? So you've got an app screen, you've got an agent screen, tasks, tools, data sources, models, and credentials. Credentials are a bit like a secret manager. So, okay, say we want to make a RAG chat app with integration to Google BigQuery. So we'll start off over here, and you can see right there, these are all the different Airbyte connections, right? All 260 or so of them. So let's select BigQuery, and then we'll just give this dataset a name. So dataset I'm going to be connecting to today is a pretty funny one. We've got Elon tweets from 2022. It's held in BigQuery. On the left side, you've got clean tweets column, and that's got all of his tweets. So let's try and sync that up. So first of all, we'll just give this a name. Then we'll give it a description. So this is very important because, as you know, LLMs are very sensitive. When you're going to use a tool or a function, it needs to have an accurate description. And this data source is going to end up being connected to a tool. So let's give some credentials. So a dataset ID is AgentCloud sample. This is the project ID. And let me just get a JSON. Sorry. So we'll paste that JSON there. So what's going on now is it's instantiating that data source test in Airbyte. And if we open up Airbyte, you will see right here that there is in fact a source that's being created and it's being tested. So we have connected to Airbyte, and the cool thing about this is you can bring your own Airbyte instance as well. So if you provide the credentials to your Airbyte, we'll just connect to that. So after a while, we have in fact tested successfully. We've connected to BigQuery, and we've returned a couple of tables. So we've got our Elon tweets table, and if you click on it, you can see all the fields from Elon tweets. Now that's returning the schema again from Airbyte. And if we keep going, the next and most important field is what field are you going to embed, right? That's the most important thing. Now over here we've got an embedding model, and in terms of our architecture, we've done it a bit of a different way. Typically, you know, and from the demo that AJ was giving, you can connect up a BigQuery data source to maybe Qdrant or to Milvus or to Pinecone. We took a bit more of an agnostic way because we're building a SaaS platform, and so we're connecting everything up to RabbitMQ, just one topic, so that we can have a bit more control and we can choose what to send over. And we've built a vector proxy app written in Rust that is going to embed and run that embedding locally. So that's going to use the GPU on the machine and run that embedding on the machine in a very performant manner. So when it comes to, for example, in this case, we're using BGE small. You know, fast embed is something that the Qdrant guys built, and we're leveraging that under the hood. But you can also connect up to OpenAI, use large 3, text 802, whatever other models you'd like to use for embedding. So once you've selected your embedding, it's going to kick off that connection. So that connection now is running in Airbyte, and what you'll see if you open up the logs, we'll see that it's connected successfully to RabbitMQ, and off it goes. The GPU on the machine, so this machine is running Core ML, that's just getting smashed right now. It's using all of that GPU to its advantage to try and embed as fast as possible. And if there isn't any GPU, we'll fall back to CPU and use as many threads as you instantiate within our environment variable. So you could say, let me use 0.8 threads, or and we'll actually allocate efficiently. So that's running. Now the next step is, okay, we've sent that data through. Where is it going? Well, it's going into Qdrant. So under the hood, again, we've got Qdrant running, and you can see that third collection that's been created. So this collection already has a bunch of points. And if we look here, if you look at that number 874 and refresh the screen, you can see it's going up, right? So eventually that's going to get to 2,668 rows, which is how many rows we had in Google BigQuery. That's a point per each tweet, per message. So we'll head back here. And now the aim is we want to chat with that data. So cool thing is we can actually start chatting while it's in flight already. So the platform has already created a tool for us. It's a very modular platform, so we've got a tool here. And in that tool, you can see this is a data set with Elon tweets from 2022. And it's just called Elon. And then I'll head over to our agent screen and make sure we've got a RAG agent. And that agent is connected to that data set. So I've prepared one earlier, and you can see we've given that agent a role, a goal, a backstory, and you've given that agent a model. So this agent is going to use GPT-4, but of course you can use any locally running model as well. And then, most importantly, we've connected that to the tool. So that's connected to the Elon tweets data set. Now, if we go over to our last screen, we've got an app screen. Now, I mean, you're seeing probably a lot of different screens, and you need to take some time to try it on your own. But we built this modularity on purpose. If you go into ChatGPT, the experience is like pretty simple, right? You're just making an app. But in this case, we wanted to provide more control because we envisage a whole company using this, where there are developers that are building, and it's in a permissioned environment, and they're building all of these apps, and they're deploying these apps to their users. So let's actually try and do a retrieval. So if we go over to this data set, we'll see that there are a couple of different points. And let's ask a question about one of them, right? So let's just pick this one. Ecological paradise plans from south portion of Big Texas. So we're going to ask it to complete this tweet. Just a random tweet. And one thing to note is, under the hood, we're running a multi-agent paradigm called Crew AI. I don't know if you've heard of that, maybe familiar with AutoGen, but we are using Crew AI under the hood. In this particular app, we're running a single agent app, so it's only one agent. You can build multi-agent apps as well in our platform, but this is just a single agent conversational app. And you can see it's already started to use the first tool, a human input tool. It's like, okay, what do you want to know? And I'm just going to say complete this tweet. And we'll see how it goes. So the thought is the user's actually asking for a completion of a tweet related to ecological paradise plans in Geo, Texas. So what's going on? Let's see, because this is all real time. So you can see it worked, right? So what happened was this agentic application is using thought and action to intuit and decide what to do. So it's realized that action is the most important action to use at the moment is the Elon tweets dataset, because we've given a description. So it's intuited that, and you can see final answer is that it looks great, however we must start to get a factory on its feet. So it's referenced that from the vector database, it's returned that, and it's completed the tweet in its entirety. And so that's AgentCloud in its completeness. There's a lot more to it. I think I went sort of over time on that, but I'll just sum up by saying, if you're looking for something to do this, so ingest, split, embed, store, retrieve, and deploy an app, end-to-end, running locally on a machine, this means the most private of situations, deploying this out to hundreds of employees across the company, having developers build apps, shipping them to their staff. This is why we've built AgentCloud. So thank you very much.
Alrighty. I know we didn't do Q&A as much in between the talks, so I wanted to see if there were any questions from the audience that they did want to go ahead and get answered. Zero pressure, and if you've lost it, you can go ahead and find these groups on LinkedIn, Twitter, and give it to them later too. But any other questions? Okay. All right. Well, thank you so much, everybody, for joining us at DataBytes. We really appreciate it. We're hoping you're going to see us at the next event as well. I'm going to be putting up here our feedback survey. We really would appreciate it if you go ahead and fill it out. We would love it if you would join us on May 7th for the event that we're going to be co-hosting with Dagster. It's going to be a great insights into everything related to reliability in modern data infrastructure. So thank you again for joining. There's still some sandwiches. You can go ahead and have a drink. We don't get officially kicked out for another 20 minutes or so. So go have fun, everybody, and thanks for joining.